Today's lesson is linear modeling. Important stuff here is not so much of linear modeling. I think we already know what linear modeling is. It's the equation there, y equals mx plus c. The m is the gradient, c is a y-intercept constant. Okay, c stands for constant. And also, this is a linear function, which is a straight line. Straight line is a linear function. Okay, simple as that. Now, important part is coming here. Now, it's dependent and independent variables. Okay, so variables are like pronumerals, like x and y. Now, y is a dependent variable, and x is independent variable. Now, what does that really mean? Do you remember number machine that we did in 701? So there was a box with a formula in it. Okay, so for example, it should be like a y equals mx plus c, but if I put x plus 4, for example, okay, that's what's in the number box, okay, number machine. Now, input is my x equals 1. I put x equals 1 into this number machine, and what's going to come out of, it's going to be y equals 1 plus 4, okay, which is y equals 5, okay. So the x is independent because it can be any value. We can choose any value, any x, put it in. But because of depends on the x value, your y value will change. That's why y is your dependent variable, because y is depending on x values. But x is free. X can be anything. Free to move around. Okay, so that's what it means. So remember that. X is independent and y is dependent. Okay? Now, next one, it says, we're just looking at this one right now. Interpreting the gradient and the y-intercept using the table of values here. Now, if we had linear function, linear equation as y equals 5x minus 4. Now, these are all the values already done for you. When we put minus 1, you will get minus 9 in y value. If I put x equals 0 into this equation, obviously I'll get minus 4. So that's the table values already done for you for y equals 5x minus 4. Now, what does that really mean? If you look at what's happening here is x is going up by 1, isn't it? When you add 1 to each x value, you will get the next x value there. So minus 1 plus 1 is 0, okay? And 0 plus 1 is 1. 1 plus 1 is 2, 2 plus 1 is 3, something like that. And then I'm looking at the y value here. It's going up by 5. So minus 9 plus 5 is minus 4. Okay, minus 4 plus 5 is 1. 1 plus 5 is 6. 6 plus 5 is 11. Okay, so that's not too bad. Now, do you remember the gradient formula? M equals rise over run. And also, we've done, previous lesson, we've done rise over run with the 2 points. And changing in y is my rise. Changing in x is my run. So we're looking at these two here. Okay. If pattern for the x is going up by 1, so I'm going to put 1 here. Okay. That's what it's going up by 1. And if I look at here, okay, y value is going up by 5. So I'm going to put a 5 there. So my gradient is 5. And that is true for this equation, right? Because it says y equals 5x minus 4. So that 5 here is my gradient. Remember, y equals mx plus c, and 5 is my gradient. Now, summary here, let's have a look. Gradient of a linear function is the rate of change of y. Now, what does it really mean? It's just like y equals something, something, something. That's what it means. Rate of change of y. If it was a rate of change of c, it would be c equals something, something, something. Okay? So that's what it means. The higher the gradient, the steeper the line. Okay? And the faster y increases relative to x. Okay? So that's obviously if steeper the line, your gradient will be higher. But if it's like really flattening out, it'll be not so steep at all. The y-intercept is the value of y when x equals 0. Okay, that's the when it cuts through the y-axis. Okay, so keep that in mind. And I'm going to do the example 6 now. Brett is organizing a 21st birthday party. All right. The total cost of the party will include $200 for hiring the hall, okay, and $120 for the music. Now, 200 and 120 it's a fixed cost, isn't it? It doesn't really matter how many people comes. You have to pay $320. Okay, that's the bottom line, the baseline. Now, $14 per person for catering. Okay, so that's something that we have to think about because it's conditional, isn't it? The table below shows the total cost C for different numbers of guests N attending the party. Now that's an N on the top and the C on the bottom. Now I would actually put X and Y here. Okay, so we know that X is what? Free to move around, free to come around. So it's independent. Y is depending on the X values. Y value will get bigger or smaller, whatever, depending on what X value is. So Y is dependent. So in here, let's have a look at question part A, example 6, part A. Which variable, N or C, is the dependent variable? C is like equivalent to Y. Y is really depending on X, isn't it? So which one is dependent? C. Next one. Find the gradient of the line relationship between N and C. We have to find the gradient M equals, we need 2 points. Aha, that's the thing. I went too far down. Okay, so I'm going to have a look at all these values here. All these values. These are like points, okay? So first one is like 80 and 1,440. Like 80 is like X coordinate, 1,440 is Y coordinate, okay? And the next one is 100 and 1,720, okay? I picked the first two values, first 2 points, if you like, because they're less number, okay? Because if I go further, I have to deal with it 100 and 130, 150, and it's like a 2,420. I mean, it's okay, but I just want to use a smaller number. So I picked first 2 because with a gradient, I need 2 points. So let's have a look at the formula that we learned. It was a change in y, so that'd be y2 minus y1, and change in x, x2 minus x1. So what am I going to do here? That's my x 1, that's my y1, that's my x2, that's my y2. So it'll be 1,720 take away 1,440, and then x2 is 100 take away 80. Okay, so if I do that, I will get 280 on the top, just use a calculator, and 20 on the bottom. So if I simplify, it'd be 14. So my gradient is 14. So that's my answer. Okay, find the vertical intercept. Now, this is like a fancy word for y-intercept, that's all. So we have to find the y-intercept. If we want to find the y-intercept, there's a one condition you have to keep, which is x equals 0. Okay, so that's what you have to think about. Y-intercept, x equals 0. X-intercept, y equals 0. So I need the formula to do this. Y equals mx plus c. Okay, but the x and y is changed. Okay, so now these ones are like c and n. So c was my y because it was dependent, and m and n plus c. N was my x, independent. So I'm going to use that now. C equals mn plus c. And my gradient was 14 from the previous part. So I'm going to put that in there, 14n plus little c. Okay, now we need to find y-intercept. Okay, so but I need to know what c is. Okay, what c is. So let's have a look. The c is actually my y-intercept. Okay, remember, this was a gradient, and this is my y-intercept. Okay, so if I want to find the vertical intercept, y-intercept, I just have to find the c. And good thing about this, I don't really have to use about x equals 0. I can just use any point from the table of values to put it in. So what I'm going to choose is I'm going to choose 100 and 100 and 1,720. Okay, that was a second point, okay, from the table. So I'm going to substitute in. So that was my x, which is my n, and this is my y, which is big C. Okay, so big C is 1,720 equals 14 times 100 plus little c. Okay, so I'm going to move c onto my left hand side because I like with everything pronumeral on the left hand side. So 14 times 100 plus c on my left is 1,720. Okay, so 1400 plus c equals 1,720, and I'm going to take away 1,400 on each side. I will get c equals 320, and therefore my y-intercept, or the vertical, we need to answer the question, don't we? So it says here the vertical intercept. The vertical intercept is 320. Just gonna write it short. Okay, so 320. Write the linear function for c. Okay, so that means we just have to write the equation. So what do we have? It was 14n plus little c. I made a mistake. There should be a big C. Okay. All right. Now, we know that C is 320. So therefore, my linear function, which is linear equation, is C equals 14n plus 320. That's it. That's all that is. That's not too bad. Now, next one. If this function was a graph, which variable would be shown on the horizontal axis? That's x-axis. Which one is horizontal one? Which is x is n, isn't it? F. What does the vertical intercept of this function represent? Vertical intercept, which is a 320, like we did here. That's our vertical intercept, 320, is the value of c when n equals 0. It is the value of c when n equals 0, which is the cost of the party, okay? Which is the, it's the C is the cost of the 21st party, okay? And when there was no one, N was the number of people, wasn't it? When there was no one, so when there are no people. Oh, that would be very sad. So that's what it is. So that makes sense because nobody comes, you still have to pay 320 because there was a music and they're hiring the hall. That's like a minimum amount that you need to pay for the party. Now, finally, we're going to use the formula here, which is good. Okay, so it'll be find the cost. So the cost was big C, wasn't it? And when there were 95 people. That's a pretty big party, isn't it? You can't do that now with the COVID. Okay, so C equals was what was it? 410 n plus 320, but n equals 95, and we need to find the C. So I'm going to put C equals 410 times 95 plus 320. So you put that in, you will get 1,650. Ooh. So when you invite 95 people, its cost is 1,650. Example 7. A criminologist, oh, interesting job, discovered that the number of crimes committed per month, C, okay, C for crime, in a big city decreased as the number of police officers, P for police officers, patrolling the city increased. Well, that makes sense. More police officers, less crime. Less police officers, more crime. Okay. After graphing her data on number plane, she found the linear relationship to be C equals minus 3p plus 3,250. Okay, well that's interesting. Part A. What is the independent variable in the relationship? Okay, so C equals the equation that given to us plus 3,250. Okay, so that's our y, right? That's our x. And we said here independent, the free to move around. That was x, wasn't it? Right? X. And therefore, P is our independent. Okay, so that was easy. Now, copy and complete this table for the equation. Now, this is something that we've done before. What I'm going to do is I'm just going to write all this equation using this P values. So I'm just going to write it here, 3,100. Okay, so You probably need to do it by yourself here, finishing off. Now have a look at this. This is interesting, isn't it? It goes down, right? When the P goes up, which is police officers, more police officers, the crime goes down. So when there were 50 police officers, was a 3,100, but if it was a 150 police officers, 2,800 crimes, and it was a 300 police officers, there was a 2,350 crimes. So it's getting smaller and smaller. And we can really see that because also it's got a negative here. So you know it's going to be getting smaller. If it's a positive, it gets bigger. But if you have to take something out each time, it'll go down. Now, well, we got to do the graph. So I'm just going to reduce this. I need to know the points. So all the points that we've done in the previous section, I'm just going to write it here. Okay, so that's what I'll go have to plot. Okay, so let's have a look. 50, that's my X, that's my Y, which is here. That's my really X here. That's my Y here. I'll just put that in so that you don't get confused. 50 and 3,100, just roughly here. Okay, I'm just going to say roughly here. 150 and 2,800. 150, 2,800, roughly here. And then 200, and that means 2,650. 2,650, roughly down here. And then 2,500 for 250. Oh, that's going to be pretty slow there. 300 and 2,350. 2,350. I'm just doing roughly. Yep, looks okay. Now, if I do it properly, that's what I've got here. Okay, can you see this? Go straight down. Okay, straight down. What is the gradient of the graph you drew in part C, and what does it represent? From the equation, C equals minus 3P plus 3,250, the gradient is minus 3, okay? And it represents the rate of change in crime, which is a C here, right? That's why it was a C equals something, something, okay? So it's the representing the rate of change in C as the number of police increases. As the number of police increases by 1, the number of crimes decreased by 3. Okay, so if I look at C equals minus 3P plus, what was it, 3,250. So if I put 1 here, so 1 police, and that will become minus 3 plus 3,250. So minus 3 take away. Okay, so that means it's decreased by 3. So 3,247. So crime is reduced by 3. Okay, so that makes sense. E. What is the vertical intercept? That was vertical intercept is the y-intercept. Okay, the C of the graph you drew in part C, and what does it represent? Okay, vertical intercept was the C, the y-intercept, which is a 3,250, because C equals minus 3P plus 3,250. That is our vertical intercept. This represents the number of crimes if no police officers were on patrol. Okay, so when P equals 0, crime is 3,250. So that's like a baseline. Next one, calculate how many crimes are committed when 100 police officers are on patrol. Okay, so now we get to use the formula, which is exciting. So because I'm excited, I'm going to use pink. Okay, so C equals, what was the formula? 3P plus 3,250. Now, when there's 100 police officers, what will happen to the crime? So I'll go C equals minus 300 plus 3,250. So if minus 300 plus 3,250, which is 2,950. Okay, so there will be 2,950 crimes when there are 100 police officers. Okay, next one. Okay, let's have a look. Calculate how many police officers now. We want to know how many police officers are required to reduce the number of crimes to down to C equals 1,900. Ooh, that's a big drop. Let's see. So our equation was minus 3P plus 3,250. So what will be, if C equals 1,900, what will be our N? I'm going to substitute in. So 1,900 now, because that's the crime, minus 3P, I don't know, 3,250. Now, what I'm going to do is I'm going to move this one to my left-hand side because I like anything pronumeral to be on my left. Equals 1,900. Okay, now let's do minus 3,250 minus 3,250. So it'll be minus 1,350. But we don't have to worry about negatives because we've both got the negatives and negatives. So I'm just going to write a 3P equals 1,350. And then P equals, I'm just going to divide it by 3 on both sides. So I divide it by 3 in a calculator, it'll be 450. So it means we need 450 police officers to reduce the crime down to 1,900. Wow, that's a lot. Anyway, that's what it is. And that's all for today's lesson. Well done, people.